We come to another session of probability. This is part 3. In the previous 2 videos, we discussed complementary events. We discussed about the sum rule. We discussed about mutually exclusive events. And we learned independent events. Now, in this video, we are going to learn a new concept, that is fundamental counting principle, a very useful and beautiful concept in probability. Try to learn, try to understand very clearly. And it is very easy. Consider the situation where you flip a coin or you roll a die. For the coin, there are only 2 possible outcomes, either head or tail. Whereas for the die, there are 6 possible outcomes. We have seen it. Now, we can state that there are a total of 2 times 6 equal to 12 total outcomes, because these 2 events are independent. 2 times 6. Now, this shortcut method is known as the fundamental counting principle. Okay? In general, if one operation can be done in m ways and another operation can be done in n ways, then the total number of different ways in which both operations can be done is m times n ways. Simple as that. Look at this example. Tarin has 5 different skirts and 4 different tops and 3 pairs of shoes. 5 skirts, 4 tops and 3 pairs of shoes. Assuming that all the colors complement each other, you can use any color. How many different outfits can she put together? So, what we have seen here, the application, we are going to apply the counting principle, the fundamental counting principle. According to that, it is going to be 5 times 4 times 3 equal to 60 different outfits. Beautiful method. Another example, Maria wants to park a gift pack as follows. Choice 1, 1 fruit out of 3 different type of fruits, 1 chocolate out of 12 different types, 1 packet of chips out of 5 different types, and 1 gift bag out of 4 different types. How many different gift bags can be made? So we have all the numbers available. So we simply multiply those numbers and we get 720 different gift bags. Application of fundamental counting principle. Consider the word CAPETOWN. You are required to form different 8-letter word. There are 8 letters in this word, CAPETOWN. Okay, you are going to arrange different 8-letter words using these 8 letters. The arrangement of the letters need not make any sense. You can use as you like any word. You can start with W or T or O, any word. How many possible arrangements can be made if the letters may be repeated? You can repeat the letters. So in the first position, we have 8 letters. In the second position, again we have 8 because we are repeating. So 8 letters again in the third position, 8 letters in the fourth position, and so on. So what is the fundamental principle? According to the principle, we multiply all these numbers. That is equal to 8 to the power 8. Can calculate on the calculator. Question B, how many possible word arrangements can be made? The same question, how many possible word arrangements can be made if there is a condition? The letters may not be repeated. So if you choose C as the first letter, you cannot use it again. Okay? So in the first position we have 8 letters. Second position how many? 7. Third position 6, and so on. So we use the fundamental counting principle and we get the answer. 8 letters are used and we get the answer 40,320 arrangements. Factorial notation, another notation in probability for an easy calculations of the numbers. Look at this. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay, can be written as 8 factorial. We read it as 8 factorial. On the calculator you can see this factorial sign. You can use it. Suppose you have 50 factorial. You cannot multiply 50 times 40 times 49 times 48. It's very time consuming. So you can use the short method of using the factorial buttons on the calculator. So that is the meaning of factorial notation. But it should come up to 1. Then only we say it is 8 factorial. Okay. Now 5 factorial, look at that. 5 times 4 times 3 times 2 times 1. 9 factorial, starting from 9, minus 1 8, minus 1 7, like that up to 1. Now there is another important number. 0 factorial is equal to 1. You can check on the calculator also. In how many ways can 6 different people can be seated in the first 6 seats in a movie theater? So in this, very clear that we cannot repeat. If one person taking the first seat, remaining only 5. So it is no repetition available there. It's not possible. So we get 6 times 5 times 4 times 3 times 2 times 1, which we know by now it is equal to 6 factorial. So practice on the calculator also using the factorial notation. The number of arrangements of n different things taken n ways is n factorial. That is the definition. In how many ways can 7 vacant places, now we come to few tricky questions. 7 vacant places be filled by 10 different people. There are 10 people but 7 vacant places. So the best way I can give you is you mark the 7 positions. 7 positions. Okay. You can put dash 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 instead of, don't waste your time in drawing columns. You just put dash dash. Now 7 places. So in the first place we have 10 different people. Okay. Now since in the second one we have only 9. And so 9, 8, 7, 6, 5. Stop there because we have only 7 places. So, and according to the counting principle, we get the possible arrangement in how many ways. Okay. So we can get the answer. Don't confuse yourself with the factorial here. We stop at 4. There is no 3, 2 and 1 there. So this is the number of ways. 604,800 ways. Beautiful idea. There are 12 singers to occupy. Okay. In how many different ways can the first three positions? Okay, we just now did that. We have three positions, 12 singers. Okay, and then we use the fundamental counting principle. The answer is 1,320 arrangements. Okay, that is 12 singers and three positions. First position, second position, and third position for the musicians. Consider the word lovers. How many letters? 6. How many 4-letter word arrangements? Okay, so by now we know the method. Okay, we can simply answer. If the letters are repeated, what is the answer? You can see that 6 to the power 4. The letters are not repeated. Remember that we have only 4 places, 4 space. So not repeated. So 6 times 5 times 4 times 3, finished. 360 arrangements. Okay, beautiful. Password to be made up using the format DDDLL. D represents the digit from 0 to 9 and L represents any letter of the alphabet. How many different passwords can be formed if the digits may be repeated as well as the letters of the alphabet? You can repeat. How many digits we have from 0 to 9? Okay, 10 digits. How many alphabets? We have 26 alphabets. Okay, so we use the previous idea here also to explain. We have 3 digits, 3 places for digits in the first 3 places, and the last 2 positions for letters, we place them, and the letters and digits can be repeated. So 10, 10, 10 for digits, alphabet 26 and 26. Now we calculate the different passwords. Look at the use of counting principle. Okay, we multiply and use the calculator and get 676,000 passwords. Another question, how many different passwords can be formed if the digits may not be repeated? May not be repeated, including the letters of the alphabet. We are not allowed to repeat. Okay? Number of passwords, 10, then 9, then 8. And letters, 26, then only 25. Finished. 468,000. Number C. How many different passwords can be formed if the digits and letters may be repeated? But there is a condition. The digit 0 and the vowels must be excluded. Look at that. So we are going to exclude 0. How many left? 9. And vowels, 5 vowels, A, E, I, O, U. So we exclude that 5. 26 minus 5 is 21. Then we use the fundamental counting principle. How many different passwords can be formed? Beautiful questions. Letters may not be repeated, and the digits 0 and vowels must be excluded. We cannot repeat the digits as well as the digit 0 and vowels exclude. Think about the numbers. We have only 9 digits. So 9 times 8 times 7. And the letters, only 21. We cannot repeat. So the next position is only 20. Use the calculator. And then lastly, how many different passwords can be formed? Digits may be repeated, but must be prime numbers. Only the prime numbers are allowed. And the letters may be repeated, excluding the first 5 letters and the last 5 letters. Okay, so prime numbers, how many? Only 4. And letters, leave the first 5 and the last 5. That is 10. 26 minus 10 is 16. So we get the answer. Okay, good people. That is the end of this part. Enjoy and learn.